And we're back.
All right, and we're back.
And we're back with another video.
Back with another video.
Welcome back if you haven't subscribed yet.
If you haven't hit subscribe, click hit the like button. Holla at me in the comments. All right. All right, go back to go back. Go back to doing your best impersonation of a typical AP student, Alfonso. All right, a couple things that we had. The mean is less than the median, or the median is greater than the mean, because the mean is pulled into the tail. And since we identified this as a skew left diagram, it would be more appropriate to describe with the median and IQR. Thumbs up, thumbs down. Let the video indicate that only one person gave a thumbs down. Would you care to elaborate on your thumbs down, or was it out of sarcasm? Sarcasm?
What?
Oh, it was legit?
I don't do the video.
All right, next question. Miss O'Connell's freshman bio class has a mean GPA of 212 with 12 students in it. However, this class, Mr. OC's stats class, has 26 and has a mean GPA of 312.
Yeah.
Yeah, what's up?
Is this true?
We smart.
Is this true? Let's just go with yes. What is the approximate mean of both classes together? Now, the actual way to find this is going to be a weighted mean, where we take her student's GPA and add our GPA over the weights, which is 12 and 26. But we have to weight the tops, where it's you have to consider how many are in that class with a 212 and how many are in that. I put 36, but I meant 26. Throw that in the calculator. I actually forgot what it was. Anyone want to double check really quick? I think it's about 2.8. You want to take credit for it? Okay. All right. However, think about this. If this is on a multiple choice section of an AP test, the key, the heart of the question is, if there's, with 26 students versus 12, the true mean should be pulled towards the class that has more students in it. So you could probably just guesstimate saying that this should be closer to the 312. 5, your SAT score is the third quartile for the senior class. What does that mean? Go ahead, Patel. You did better than 75% of seniors. What else could it say? 25% did better than you.
I said that,
Go ahead.
I had said basically that their score was, 75%.
In the 75th percentile. That's good. Yeah. Questions, comments, concerns? All right, great. 6, suppose a normal model describe the amount of hot dogs a contestant eats in a competitive hot dog eating contest. Anybody watch that on 4th of July? That's the thing. Joey Chestnut really ate 70 hot dogs in 10 minutes. Let's just say that he had a z-score of 2.8. What does a z-score of 2.8 mean? Go ahead, Stevie. Yeah, he ate 2.8 standard deviations above average. All right, moving on. 7, describe the key differences between a stem and leaf plot, dot plot, and histogram. Patel, what are you telling me? Mm-hmm. Histogram doesn't preserve individual data. Where stem and leaf and dot plot does.
Histogram space matter.
What about a box plot? Is a box plot going to take individual data? Is it going to preserve individual data points?
No.
No, it won't. Are there any outliers in the data? Well, do you remember, you need to remember that high fence and low fence are things. And what's the formulas? That's strange. All right, you need to remember that the high fence, Josh, what was it? High fence. Or no, what was the formula? Well, not 0.15, 1.5 times the IQR. And then what's the other number? Q3. Low fence, Q1 minus that formula, 1.5 IQR. IQR, remember, is just all right, so you got to remember that the IQR comes from Q3 minus Q1. So if we set this up, the low fence, what's Q1?
150.56.
Minus 1.5 times that minus that, I think, is 46, roughly. Is that right? So what's the low fence then?
2967.
What's that?
2967.
I don't think it's going to be that. Okay, so 66 minus 1.5 times 46 is -3. Determine, are there any low outliers? Are there any low outliers first? You said yes. What are they? 50 is lower than our low fence?
Oh, no.
No, there are no low outliers because the minimum in the data set is 50. Our low fence is at -3. Find the high fence, and that's Q3 is 112 plus 1.5. IQR is 46. Josh, what is it? 181 is right. Now go back, look at the data. Are there any high outliers?
No.
No, because our maximum is 134, our high fence is at 181. So hypothetically, if there was a maximum of 200, are there any high outliers? Yes, then anything above that 181 would have been an outlier. Okay. All right, summary statistics that are changed by multiplying by a constant. If you don't know, try an experiment really quick. If we had, really quick, does anybody actually know this? Does anybody remember this? Summary statistics that are changed by multiplying by a constant. Mean changes, yes. Median changes. You said the rest don't, though, so let's experiment really quick. If you don't know, let's experiment. Let's start with the data set 1, 2, 3, 4, 5. And then we multiply everything by a constant, let's say 10. 10, 20, 30, 40, 50. Did the mean change? Yeah, the mean of the first one was 3, now the mean is 30. Did the median change? Yeah, from 3 to 30. Instead of calculating standard deviation and IQR, both of those measure spread. So the easiest way to calculate spread is range. So what's the range of the first data set? 4. 5 minus 1 is 4. What's the range of the second data set? 40. So did the statistic describing spread change? From 4 to 40, did it change? Yes, it did. So range changed, and range measures spread. So that means anything that measures spread changed. IQR changed,